here, and today we're going to be doing Unit 9, Notes 8. So we're going to be talking about surface area and volume of similar and congruent solids. So I do want you to take the time to write it all the way down. I did on my key, you can do it on yours. So how do we know when two solids are similar? If you want to, you could also just write a list of how you know when they're similar. So two solids are similar if they have the same shape and the ratios of their corresponding measures are equal. So first of all, we need to go cone to cone, rectangular prism to rectangular prism, and so forth. And the ratios of their corresponding measures need to be equal. So the scale factor has to be the same. It doesn't mean that the sides have to be the same. So the radiuses don't have to be the same length, but the ratio of the two radii needs to be the same as the ratio of the height, and so forth. And as an added part, all spheres and cubes are similar, just because spheres are always going to look like a ball, so they're all going to be similar to each other. Cubes are made up entirely of squares, so they're always going to be similar to each other. Let's take a look at congruent. So congruent solids are only congruent if their corresponding angles are congruent, so any angles of the base or whatever, they all need to be congruent. Corresponding edges are equal. They need to have the same height. They need to have the same radius. They need to have the same base length. Corresponding faces are congruent. The area of each of the faces, the lateral area, the surface area, all of that has to be congruent. And likewise, their volumes have to be equal. So jot down something from that will help you to know when solids are congruent. So let's take a look at this first one. So we're going to determine whether these solids are congruent, similar, or neither. And if they're similar, we're going to figure out the scale factor. Well, clearly they're not congruent because our base edge and our height are not the same measure. So our hope is that it's similar, and if it's not similar, then it's neither. Okay, so let's take a look at the scale factor for the height to start off with. Okay, so for the height, what we're going to do is we're going to take one side divided by the other side. So 4 over 6, because that's the height of both of these prisms. 4 divided by 6, if you reduce that fraction, you end up getting 2 over 3. Now let's take a look at that base edge there, and we're going to calculate out the scale factor of the base edge. So that's going to be 8 centimeters to 12 centimeters. And I want to write it the same way. So I have 8 divided by 12. Well, 8 and 12 are both divisible by 4, so you divide them both by 4 and you get 2 over 3. So if you notice, the two scale factors or the ratios between the two sides are the same. So that makes these two similar. So these are similar solids. Let's take a look at, and our scale factor, sorry I didn't make note of that, our scale factor for that is 2/3, if you want to make a note that that's your scale factor, because it asks to state that as well. Okay? Alright, let's take a look. Hey, let's go backwards apparently. Okay, let's take a look at number 2. So if we take a look, we have 2.5, and that's going to be the same as 6, we don't know. Whoa, let's compare sides, we do know. So we have 3, and that's going to be the same as 1.7. 6.2 is going to be the same as 3.4. 2.5 is going to be the same as 1.5. That's just based on where we're located. Base of the base, height of the base, height of the base, height of the prism. So let's go ahead and let's do that. So let's talk about the width of that triangle. So first for the width, we're going to do 3 over 1.7. So 3 divided by 1.7. And when you divide those out, you get about 1.76. We can't really reduce the fraction when there's a decimal in. So we're just going to check using the decimal. I almost had a list there, decimal. So let's take a look at the length. So we're going to take 6.2 divided by 3.4. So 6.2 divided by 3.4, and you get 1.82. So it's not congruent because none of the side lengths are the same, and also none of our scale factors are the same. So then these shapes are neither congruent or similar. So that's your final answer for number 2. Let's take a look at 3, looking at these cones. So let's take a look first, and we notice that the radius is not the same length, and neither is the slant height. So then it can't be congruent. So let's check that it's similar. So for the radius, what we're going to do is we're going to take one side of the radius over the other. So we're going to do 5 over 6, maybe 5 over 6, and when you divide that out, you end up getting 0.83. So that's your ratio for the two radius. Now let's take a look at the slant height. So for the slant height, we're going to do 12 divided by 14.4. And when you divide those out, you get 0.83. So what we notice is that those two are the same. So that means that these are going to be similar, and that their scale factor is going to be 5/6. So they're similar, and your scale factor is 5/6. Now let's take a look at number 4. So it says the cubes of the right are similar. Well, we know that, right, because they're cubes. And their scale factor is 3:2. So we want to find the surface area for each figure. So let's go ahead and let's do that. So we have 3 for each of the sides and also 3 for the height because it's a cube. 2 for each of the sides and 2 for the height. Now remember to calculate out surface area. That surface area is equal to your perimeter times your height plus 2 times your base. So let's go ahead and let's calculate out the surface area of the first one. So the perimeter, 3 plus 3 plus 3 plus 3. Your perimeter is going to be 12 for that one. And the height of the cube is 3. So 12 times 3 plus 2 times the area of the base. Well, the base is 3/3. So to get the area of the base, it's 3 times 3, which is 9. So then in my calculator, I'm doing 12 times 3 plus 2 times 9, and that gives me 54 centimeters squared for the area. Now let's take a look at the surface area. Let's take a look at the surface area of the second one. So to get the perimeter, I'm going to have 2 plus 2 plus 2 plus 2, which is going to give me 8. So my perimeter is 8, and my height is 2. Plus 2 times the area of my base. Well, the base is going to be 2 times 2, so the area of the base is going to be 4. So in my calculator, 8 times 2 plus 2 times 4, which is 24 centimeters squared. So let's go ahead and let's take a look at our bases. Okay, so when we take a look at our volume, take the volume of the figure, remember the volume is simply the area of the base times the height. Well, for the first one, the area of the base we found to be 9. And then we're going to take the area of the base times the height, which is going to give us 27 centimeters cubed for the volume of the first box. Then we're going to take a look at the volume of the second box. Well, the area of the base we found to be 4 times the height, which is 2, and that's going to give us a volume of 8 centimeters cubed. Okay, so now let's go ahead and let's take a look at scale factors for volume and area. So if we have two similar solids that have a scale factor of A to B, then the surface area of their ratios of A squared, B squared, and the volumes have a ratio of A cubed, B cubed. Now let's take a look at what we did. So the surface area of the first one was 54. The surface area of the second one was 27. So we have 54 divided by 27. Ooh, that got messy. Let me try that again here. This is not cooperating with me today. So we have 54 divided by 27. Well, both of those are divisible by 8. And when you divide them by 6. And when you divide them by 6, goodness, I'm sorry, by 3. Both those are divisible by 3, so then you get the scale factor 9/4. Remember that our original scale factor was 3/2 for I'm looking at problem 4. Well, 3 squared is 9, and 2 squared is 4. So that means that that works for our surface area. Now take a look at our volume, and we got 27/8. If we take a look and we take 3, and we multiply 3 times 3 times 3, or 3 to the third power, what do we get? 27. When we take 2 and we multiply 2 times 2 times 2, or 2 to the third power, we get 8. So that is our volume scale factor, and it is our original scale factor cubed. So let's take a look at number 5. It says two similar cones have a radii of 10 and 15. What is the ratio of the surface area of the small cone to the surface area of the large cone? So remember that surface area means we are going to square our ratio. Okay, so we have 10/15. Now let's go ahead and let's reduce that scale factor. So they're both divisible by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So we have the scale factor of 2/3. Now, to get the scale factor of the surface area, we need to square both of those. So 2 squared is 4, and 3 squared is 9. So the scale factor of the surface areas are 4/9. Next, let's take a look at number 6. Similar cones have a radii of 9/12. What is the ratio of the volume of the smaller cone to the volume of the larger cone? Well, first let's figure out what our scale factor is. So it's going to be 9/12, but I like to reduce that fraction. 9 and 12 are both divisible by 3, so then I get 3/4. Now, in order to get the volume, we need to cube 3/4 and 4. Or 3 to the third power and 4 to the third power. Remember to cube something in your calculator. You're going to take 3, and then you're going to look for the key that looks like that and raise it to the third power. Or that's really the same as 3 times 3 times 3, which is going to give you 27. And then 4 to the third power is the same as 4 times 4 times 4, which is going to give you 64. So this right here represents the volume scale factor. So that concludes your note video for today. Go ahead and show me your completed note sheet once you are done. Thanks for listening.